Okay, let's jump right into this explainer. Today, we're looking at a deep tech breakthrough that honestly sounds like it was ripped straight out of a sci-fi movie, but it's real. We're talking about a technological revolution that promises to unlock a world with literally limitless clean energy. It sent absolute shockwaves through the global nuclear community, and the whole thing started in a tiny lab in Bengaluru, India.
Just imagine it for a second. What if the world never, ever ran out of electricity? A future where the whole concept of pollution is entirely obsolete. A world where nations aren't relying on fossil fuels, coal mines, or foreign energy imports just to keep their lights on. Well, that is the ultimate promise of nuclear fusion. It's essentially the holy grail of modern physics, and today we're going to see how a remarkably young Indian startup just built a machine that brings us one step closer to that reality.
Here's our roadmap for today. We'll start with the ultimate energy source, then meet PRAGYA, the mini-sun. After that, we'll break down their David versus Goliath strategy, look at India's government milestones, and finally, zoom out to the global fusion race.
All right, Section 1, the ultimate energy source, powering the stars. So you probably know the basics, but let's quickly clarify the absolute game changer here. Right now, the world's nuclear plants run on fission. That means splitting heavy, rare atoms like uranium. And sure, fission works, but it creates dangerous, radioactive waste and carries the risk of runaway chain reactions. Fusion, though, it's the exact opposite. It safely mimics the sun by merging incredibly light, abundant atoms together, specifically deuterium. When they merge, they release a massive amount of energy, but with zero radioactive waste. The only byproduct is completely safe, harmless helium. Plus, there is absolutely no risk of a meltdown.
But to actually make fusion happen, you need a highly specific piece of hardware known as a tokamak. Originally invented in the Soviet Union, you can basically think of a tokamak as a giant magnetic vacuum donut. Inside this donut, gas is heated up to tens of millions of degrees until it becomes this super hot plasma. Now, obviously, no physical material on Earth can hold something that hot, right? So the tokamak uses incredibly powerful magnetic fields to suspend the plasma in midair. When the atoms inside that suspended plasma smash into each other, they generate energy, exactly like our sun does.
Moving on to Section 2, meet PRAGYA, the mini-sun.
Enter PRAGYA. That's a name that literally translates to wisdom, which is pretty fitting for a machine that represents this level of human ingenuity. It was built by Pranos Fusion Energy, a deep tech startup based in Bengaluru that is, get this, only 2 years old. I mean, historically, this field has been totally dominated by massive, well-funded government institutions. But Pranos, backed by scientists from the IISc and JNCSR, completely broke through that wall. Sources are even calling this India's SpaceX moment because it proves that a lean, private company can lead the charge in hardcore physical science, not just software.
And here's the part that's truly wild. $417,000. Back in May 2025, an angel investor named Rahul Seth provided that seed funding. Now, for a nuclear fusion project, that is practically pocket change. But the team at Pranos stretched every single penny of that extremely lean budget to actually build this thing.
Because they were on such a shoestring budget, they had to be incredibly smart about the engineering. Technically, PRAGYA is classified as a compact, low aspect ratio tokamak with a spherical architecture. The specs are just fascinating. It operates with a tiny 0.40 meter radius, a 0.1 Tesla magnetic field, and a plasma current of 20 to 25 kiloamperes. Basically, they engineered an unbelievably tight, highly efficient magnetic environment to confine that plasma. To really wrap your head around this, you have to look at the scale. Over in France, you've got the massive international ITER project, which has a gigantic radius of 6.2 meters. And then you have little PRAGYA, sitting at just 0.4 meters. I mean, it is less than 10% the size of ITER. It's genuinely one of the smallest functioning fusion reactors on the planet.
Which brings us to Section 3, the David versus Goliath strategy. So you might be wondering, why build such a tiny machine when the rest of the world is building these absolute giants? Well, it's a brilliant strategy, really. Giant government megaprojects face two huge enemies, scale and cost. By making PRAGYA compact, Pranos completely bypasses those hurdles. It drastically lowers construction costs and lets them build and deploy super fast. If you can quickly figure out how to confine a strong magnetic field in a small space, you can iterate and learn way faster than a mega project that takes literally decades just to assemble.
Now, a quick reality check. PRAGYA isn't going to be plugged into the power grid tomorrow. That was never the goal. It was specifically built as a physical test bed. Why? Because trying to control superheated plasma is basically like trying to tame a wild, fiery horse. It is notoriously unstable. So they're using PRAGYA to trial domestic superconducting magnets and rigorously test their proprietary plasma control software, which they call Zyga, along with testing magnetohydrodynamic stability. The data they pull from this little machine will pave the way for the much larger reactors they're planning to build next.
All right, Section 4, India's government milestones.
To really appreciate what this tiny startup just pulled off, we got to look at what the Indian government has been doing for decades. Historically, state-run institutions have dominated this space. They've successfully built domestic tokamaks like Aditya-1, Aditya-2, and the highly advanced SST-1. On top of that, India is actually the 7th major partner in that massive 35-nation ITER project in France. In fact, India built and supplied ITER's cryostat, which is essentially a gigantic, mind-bogglingly complex refrigerator designed to keep the world's largest reactor cool. And get this, India's government-run SST-1 reactor successfully achieved plasma temperatures of 200 million degrees Celsius. Let me just put that into perspective for you. That is roughly 20 times hotter than the core of the actual sun. 20 times! It's a staggering achievement, and it proves just how deep the well of nuclear expertise really is in India.
Finally, Section 5, the global fusion race.
Let's zoom out for a second and look at the ultimate global scoreboard. We're talking about a modern-day space race here, and the wealthiest nations on Earth are pouring billions into it. China is moving incredibly fast. Their East reactor held 70 million degrees for over 1,000 seconds. The US achieved a historic milestone called net energy gain, using highly advanced lasers. South Korea maintained 100 million degrees for a solid 30 to 40 seconds. It is a highly competitive, almost Cold War-esque race for ultimate energy supremacy.
But here's the absolute coolest part. The race isn't just between massive, slow-moving governments anymore. Private capital is flooding the zone. Over in the US, startups like Commonwealth Fusion Systems and Helion Energy are raising billions of dollars. Actually, scratch that. Microsoft even signed a power purchase agreement with Helion, which is unprecedented. And now, PRAGYA has totally opened the floodgates in India, paving the way for a booming ecosystem of private domestic startups like Highlander and Anubal Fusion.
Which leaves us with this final, provocative question straight from our sources. With this brilliant blend of deep government expertise and this newly unleashed private sector agility, could India actually be the nation to build the world's first commercial fusion power plant by 2040? PRAGYA might just be a tiny $417,000 testbed today, but it represents a monumental shift. It proves that changing the world doesn't always take a multi-billion-dollar budget. Sometimes all you need is a bit of wisdom, a really tight magnetic field, and a whole lot of ambition. Thank you so much for joining me on this explainer. Definitely keep your eyes on this space because the future of energy is literally being written right now.